Hey guys, welcome to Sleepy Scientist Tells. Tonight we're doing something a little risky. You're going to stay awake, not for a late-night movie marathon, not for a final exam cram session. No, you're going to try and live without sleep. At all. Ever again. Sound dreamy, or a little like the opening act of a slow-moving science horror. Either way, you probably won't survive this. But don't worry, this isn't a punishment. It's a journey. One that begins with a single skipped night and spirals into strange biology, cosmic confusion, and yes, a few surreal moments where your brain starts seeing things that aren't there. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And if you feel like sharing, let me know where you're listening from and what time it is where you are. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You've just decided not to sleep tonight. Maybe it's to test yourself. Maybe you're just curious. At first, it doesn't feel like much of a change. You're alert, maybe even a little excited. Your senses feel sharper, your thoughts a bit louder. There's something faintly magical about staying awake while the rest of the world winds down, like you're on a secret mission in a city that's gone quiet. Your body still runs on momentum. The day's caffeine still hums in your veins. Lights dim around you, but your eyes remain open, drawn to the faint flicker of a street lamp or the muted glow of your phone screen. You feel invincible, like your mind is in that weird, sharp-edged state it hits at 2 a.m., where every thought feels just a little too profound. But as the hours drag on, things start to wobble. Time loses its grip. A single minute stretches like taffy, and your brain flits from topic to topic with increasing impatience. That mental clarity you felt earlier, it starts dissolving, not gone, just fogged. Like a window slowly steaming up from the inside, here's what's happening beneath the surface of your brain runs on cycles. Natural, predictable rhythms regulated by your circadian clock, a tiny but powerful cluster of neurons in your hypothalamus called the suprachiasmatic nucleus. It responds to light cues, manages hormone release, and keeps the gears turning on your internal schedule. But when you skip sleep, the gears begin to grind. Without sleep, adenosine, a molecule that builds up in your brain throughout the day, continues to rise. It's like digital lag for your mind. You're still receiving input, but everything's just a little delayed, a little heavy. Normally, sleep would flush that adenosine out, but not tonight. Weird tidbit. Caffeine doesn't remove adenosine. It just masks it, by blocking the receptors that tell your brain it's tired. So, if you're chugging coffee to push through, you're basically duct taping over your engine light. The tiredness is still building underneath. Still, you sit, awake, breathing in the soft hush of the night. Somewhere your body begins adjusting. Your core temperature dips ever so slightly, as if confused why you're still conscious. That's part of sleep prep. By the way, your body naturally cools when preparing to shut down for the night. So now you're a little cold, a little twitchy, and your toes are wondering why they aren't under a blanket. It's okay. You're only about 16 hours into this experiment. People have gone far longer. In fact, there's a man named Randy Gardner who once stayed awake for 11 full days, 264 hours, just to set a record. He was 17 years old. By day 2, he was irritable and uncoordinated. By day 5, he was hallucinating. But the strangest part, after finally sleeping again, he recovered faster than expected. Scientists were baffled. How does the brain bounce back so quickly from something so destructive? That leads us to the first scientific mystery of the night. Why do we need sleep at all? For something we spend nearly a third of our lives doing. Science still doesn't fully understand its exact purpose. Theories abound: memory consolidation, cellular repair, energy conservation. And yet no single answer fits every puzzle piece. Sleep is still one of biology's deepest yawns. Outside your window, the world is now fully asleep. There's a gentle silence. Your neighborhood hums with refrigerator motors and the occasional rustle of wind in trees. Inside your body, however, it's anything but calm. Your organs, your muscles, your neurons, they're beginning to grumble. Without sleep, your brain doesn't get its regular deep clean cycle. The glymphatic system, which works like a waste removal crew during the night, stays dormant. The result, beta amyloid, a protein linked to Alzheimer's, starts piling up like uncollected garbage in your mental alleyways. It's subtle for now, a little forgetfulness, a skipped word, a moment where you walk into a room and forget why. But that's just the beginning. The real fun starts after 24 hours when your neurons begin sparking like crossed wires and your reaction time's slow to that of someone legally drunk. So yes, pulling an all-nighter basically turns your brain into a tipsy raccoon holding a calculator. Still, the idea of not sleeping feels powerful, like you're stealing hours back from time itself. But your body disagrees. Deep down, it's already negotiating, already compromising. You may feel fine on the surface, but internally your systems are writing complaints. And one by one they'll start filing reports. But that's for later. For now, you lie there, awake, curious, still in control. The first sunbeam slips through the edge of the curtain. It's morning now, officially. You've made it a full day without sleep. And oddly, you don't feel as bad as you thought you might. There's even a moment of pride, a smug little voice in your head that whispers, "See, who needs sleep?" But that voice is unreliable. Your body isn't impressed. Behind the scenes, it's quietly hitting panic switches. Right now, you're entering what scientists call the 24-hour mark, and your brain has begun working harder just to keep basic processes running. Like a factory without a night crew, it's forced to stretch its resources thin. The lights are still on, but the janitorial staff didn't show up, and the floor's getting sticky. Your prefrontal cortex, the area responsible for decision-making, emotional regulation, and impulse control, is now behaving like a toddler who skipped nap time. It's less efficient, more emotional, and prone to dramatic overreactions. So if you suddenly get weepy over a cereal commercial or feel unreasonably angry that your sock won't cooperate, yeah, that's the sleep deprivation talking. Here's the real science bit it. A sleep-deprived brain shows decreased glucose metabolism in the prefrontal cortex, which means it's burning through fuel faster and getting less done. It's like putting your laptop in high-performance mode, but forgetting to plug it in. Meanwhile, your amygdala, the emotional center, is more active than usual. Researchers at UC Berkeley found that sleep-deprived individuals have a 60% increase in amygdala reactivity. Translation: you're more likely to overact to stress, get anxious over small things, or pick fights with inanimate objects. The drama queen energy, it's now full-blown royalty. You may also start noticing subtle coordination glitches. You fumble your phone more often. Your handwriting goes from okay to, was this done mid-earthquake? Your brain is starting to misfire just slightly. Motor skills, once automatic, now need conscious effort. Even blinking slows down. And when your eyes do close, they stay closed for longer, often without you noticing. This brings us to the first weird tidbit of today: microsleeps. These are tiny, involuntary naps, lasting only a few seconds, where your brain essentially goes, "Nope, I'm out," and shuts off. You might be staring at your screen 1 second, and then nothing. You blink and realize you lost 3 seconds. It's as if your brain is sneaking sleep through the back door while you're not paying attention. Most people don't even realize they've had one. And get this, during a microsleep, parts of your brain actually go offline while others stay alert. Imagine walking down a hallway and suddenly the lights in one room just flicker out. That's your brain's power grid rationing energy. This raises a fascinating open question in neuroscience. Can the brain rest in patches like dolphins? Dolphins sleep one hemisphere at a time, keeping the other half alert for predators. Some scientists suspect that human brains might do micro versions of this when extremely tired. One hemisphere shows slower wave activity, like it's catching some quick Z's. The research is ongoing, but it suggests we might have more internal sleep mechanics than we realize. Back to you. You're still going, though maybe with a little more effort. Your thoughts are slower now. The world has taken on a kind of underwater feel. Muted, floaty, dreamlike. Light seems a bit too bright, and shadows feel a little too heavy. Your depth perception is off, your memory slippery. You walk into the kitchen and forget what you came for. You double-check your phone only to realize you already read that notification. Twice. But you're awake. You drink some water, maybe eat a little food, but even digestion feels sluggish. That's because your gut-brain axis, the intimate line of communication between your digestive system and your central nervous system, is now out of sync. Sleep regulates hormone production, including ghrelin and leptin, which control hunger and satiety. Without sleep, ghrelin spikes, hello, hunger, and leptin drops, goodbye, fullness. So now you're tired, cranky, and strangely obsessed with snacks. If you feel like you're craving carbs or sugar right now, that's completely expected. Your body's trying to compensate for its energy deficit. It wants fast fuel. That's why sleep-deprived people often reach for donuts instead of kale. And honestly, who can blame them? But the toll is stacking up. Your immune system is also quietly protesting. Without sleep, your body produces fewer cytokines, the proteins that help fight off infections. One sleepless night weakens your defense system. You're now more susceptible to viruses. Yes, staying up all night to finish a paper or watch that entire series might actually invite the flu to come knocking. Still, you power through. A warm drink helps. A cold splash to the face offers a temporary jolt. But mostly, you're coasting now, on habit and inertia. You might start to experience hallucination-like symptoms, called hypnagogic imagery, flashes of lights, patterns, or phantom sounds that appear just at the edge of perception. They're harmless, but definitely surreal. Like your brain is leaking dreams into your waking world. You blink again. Long. Almost like your eyelids are trying to convince you to surrender. They don't care about your willpower. They only know the rhythm. The rhythm you're now breaking. Outside the sun is higher now. The world is fully awake while you paradoxically are drifting. Conscious, yes, but just barely, like a leaf spinning in slow water. This is the zone where time frays, and you're still not sleeping. You're still with me. Eyes may be a little heavier, focus flickering like a candle in a quiet room. It's now been 36 hours since you last slept, and your body is no longer politely asking. It's begging. Every cell in your system is whispering the same thing: please rest. You're in what sleep scientists call the cognitive impairment zone. At this point, your reaction time is about as bad as if you were legally drunk. But unlike being drunk, this doesn't come with the usual warning signs. No slurred speech, no stumbling gait. You might still seem alert, but under the surface, your brain's firing patterns are faltering. You're making more mistakes, even if you don't notice them. And here's the real kick: your self-awareness is also compromised. In other words, you're too sleep-deprived to realize how sleep-deprived you are. A bit like handing your car keys to someone who insists they're fine after 9 espressos and 3 hours of sleep. Not great. Behind your eyes, your hippocampus, the memory center, is flailing. Short-term memory becomes porous. Like trying to pour tea into a colander. You read a paragraph and forget what it said by the time you reach the next line. Your brain keeps buffering. Everything takes longer. You're trying to remember the thing. With the guy from the show. You know, the one with the face. Yeah, that's about where we're at. But there's still a strange beauty in it. You start to feel a bit untethered. Light. The world has an echo to it now, like walking through a dreamscape with cotton in your ears. It's not unpleasant, just unreal. You might find yourself laughing at odd moments, or pausing to watch dust swirl in the sunlight like it's a profound cosmic ballet. This is partly because your default mode network, a brain system involved in daydreaming and introspection, becomes more dominant when you're sleep-deprived. The rational, task-focused parts of your brain dim down, and your imagination slips into the driver's seat. The result: surreal thoughts, odd connections, free-floating creativity. It's why some artists actually seek out mild sleep deprivation, though no one recommends the full 36-hour experience unless you enjoy accidentally putting your socks in the fridge. Here's a strange science tidbitting. Studies on rats show that prolonged sleep deprivation can lead to the buildup of waste proteins in the brain, specifically beta amyloid, one of the hallmarks of Alzheimer's disease. The human brain has a system called the glymphatic system that flushes out toxins during deep sleep. Without it, your brain becomes, well, messy, like a party house that never gets cleaned up. And yet, scientists still don't fully understand why we sleep. We know what happens without it, but the precise mechanism, the why, behind the need, remains one of neuroscience's biggest mysteries. Some theories say it's for memory consolidation. Others argue it's for cellular repair or energy regulation. But none quite capture the full picture. It's like trying to describe a forest by only counting the trees. Back in your body, other systems are breaking rhythm too. Your circadian clock, the internal 24-hour timer governed by your hypothalamus, is now completely off kilter. It's like trying to dance to music that keeps changing tempo. Hormones like cortisol and melatonin are misfiring. Your temperature regulation is fluctuating. Even your skin may look paler, duller. Yes, sleep is skincare. Who knew? You've entered a phase where your body begins to confuse wakefulness with dreaming. The boundary between reality and hallucination grows thinner. You may hear phantom whispers, See shadows that aren't there. That coat hanging on the chair. Did it just move? Don't worry, your brain's not broken. It's improvising. Your REM pressure is building. The intense biological drive to enter REM sleep, where dreams occur and emotional processing happens. But since you're not letting yourself sleep, your brain begins inserting dream elements into your waking life. It's called REM intrusions. The surrealism isn't imagined. It's neurological steam leaking out of a closed valve. Still, somehow, you're functioning. Not well, not efficiently. But you're here listening, breathing, maybe swaying slightly like a tree in slow wind. Here's a comforting callback. Remember those nasal turbinates we talked about earlier? They're still working, softly curling and humidifying each breath. They don't care how tired you are. Your body, in all its evolutionary wisdom, keeps trying. And speaking of trying, your heart is too. Sleep deprivation increases blood pressure and puts extra strain on your cardiovascular system. One sleepless night can reduce your heart's ability to regulate itself during stress. Long term, there's a measurable increase in risk for heart disease. The science is sobering, even if you're too fuzzy to feel it now. But let's ground ourselves again. You take another slow breath. You're still safe, still whole, still here. You glance at the clock. Maybe it's morning again, or maybe it's just a very bright cloud outside. Time has lost its texture. Minutes stretch like taffy, hours repeat themselves. You're not sure how long you've been listening, and yet, you're still not asleep. You're now nearing 48 hours without sleep, a full 2 rotations of the earth while your body has refused to lie still and let go. And yet, here you are, blinking slowly, drifting in and out of focus, somewhere between awake and a sentient raisin. Your eyes might burn a little. Not from light, really, but from sheer exhaustion. Tiny muscles that usually coordinate eye movement now twitch and lag. Your saccadic responses, the quick jumps your eyes make to scan or read, have slowed. You're scanning less, processing less, but strangely feeling more. Or is it less? Hard to say. Around this point, most people start experiencing something called microsleeps. These are brief lapses in consciousness, usually lasting just 1 to 10 seconds. Where your brain literally shuts down, even while your eyes remain open. You could be reading, walking, talk on, and for a moment gone. The lights are on, but the brain is rebooting, and the weird part, you often don't know it's happening. Your mind skips a beat and seamlessly sews together the silence. It's like sleep is hacking its way in through the side door, refusing to wait for permission. If you were hooked up to an EEG, measuring your brainwaves, it would look as though your theater waves are increasing. These are slow, rolling patterns usually associated with drowsiness or the early stages of sleep. Even while awake, your brain is dipping into lower frequencies. You're floating somewhere between conscious awareness and dream logic. Have you noticed how quiet the world has become? Not in terms of sound, necessarily, but attention. Sleep deprivation narrows your attentional spotlight. You focus on one thing while everything else fades to background static. It's why tired drivers miss obvious dangers. The brain is running on backup power, dimming non-essential systems just to stay upright. And now for a weird science tidbiting, there's a phenomenon known as paradoxical alertness, where sleep-deprived people sometimes experience brief periods of sharp mental clarity, almost like a second wind. But it doesn't last. It's your body using emergency fuel, squeezing every drop of adrenaline and cortisol it can produce before the crash. A flicker of lightning before the blackout. By now, your emotional regulation system is wearing thin too. Specifically, the connection between your amygdala, your brain's fear and emotion center, and the prefrontal cortex, the part that usually calms it down. That connection weakens with lack of sleep. The result, mood swings, overreactions, laughing too hard, crying over cereal commercials. The emotional brakes are failing. Your body is still pumping blood, digesting food, blinking, swallowing, but everything feels a few frames behind. You're like an old movie reel where the audio doesn't quite sync with the action. Welcome to the sensoromotor decoupling zone. There's a beautiful irony here. You're exhausted, but your sympathetic nervous system, the fight or flight response, is still humming like a tired motor. Your body is quietly panicked. It thinks something is wrong because, well, something is, but can't pinpoint it. So your heartbeat ticks faster. Your pupils dilate. Your gut slows digestion. You're stuck in low-grade survival mode. Even while sitting still, and yet, despite the wear and tear, you're still listening, still breathing, still here. And that's incredible. Let's pause for a second. Inhale slowly through the nose. Remember those nasal turbinates we talked about earlier, still swirling the air gently, still moisturizing each breath. The air enters your trachea, travels down its reinforced rings, and finds its way back to the bronchioles, the tree-like branches inside your lungs. At the very tips, the alveoli do their delicate trade oxygen in, carbon dioxide out, and somewhere beyond those tiny air sacs, your red blood cells are still bustling. Each hemoglobin molecule is still offering oxygen like a polite waiter with a glowing tray. Even now, your mitochondria are chugging away, transforming glucose into ATP, the tiny spark plugs of your entire body. Meanwhile, a quiet debate continues among scientists. Is chronic sleep deprivation reversible? Can the brain fully recover from repeated sleepless nights, or are there long-term cognitive consequences? Some studies suggest neuroplasticity, the brain's ability to reorganize, can help repair the damage. Others warn that certain losses might be permanent. We just don't know yet. But here's what we do know: your brain is resilient. It evolved to endure famine, stress, even danger. And while sleep is essential, the body can survive far longer than we once thought. That said, you are now deep in the twilight zone of consciousness. Thoughts loop. Reality blurs. Memories double back. You might feel like you're dreaming while awake, or waking while dreaming. It's not unpleasant, just surreal. And as strange as it all seems, you're not broken. You're experiencing the full range of human cognitive resilience. Your brain is trying to save you in the gentlest way it knows, by drifting, slowing, softening. So let yourself relax into that. You've made it 48 hours without sleep. You're in uncharted territory now, navigating it with a flashlight made of neurons and willpower. But you're still here, still whole, still glowing faintly in the dark. At this point, 72 hours without sleep, you are not so much awake as untethered. Your body is here in this quiet space, but your mind, it's like a balloon on a long string, drifting toward the ceiling, floating farther with every heartbeat. Your thoughts start to unravel into loops. You forget what you were just doing. A sentence trails off halfway, and you can't quite remember what you meant to say. The prefrontal cortex, which handles logic, planning, and decision-making, is now operating like a half-charged phone, laggy, unreliable, and prone to sudden crashes. There's a term for what's starting to happen: cognitive fragmentation. It's as if your mind is no longer a clean movie reel but a series of jumpy clips, snippets that don't quite connect. You might start a task and forget midway through why you even started, or get lost in thought, forget what the thought was. And then there are the hallucinations. Yes, actual perceptual hallucinations. Not because you're crazy, but because your visual cortex is running on fumes. It starts misfiring, filling in the blanks with whatever your mind can piece together. You might see shapes that aren't there, hear footsteps, feel as if something's brushing your skin. Your brain is trying to simulate reality in the absence of sufficient data, like a computer loading corrupted textures in a video game. Interestingly, these hallucinations are often influenced by your environment. A shadow becomes a figure. A coat on a chair seems to breathe. Nothing is inherently frightening, but it's certainly surreal, like dreaming with your eyes open. And here's a strange fact. Studies on extreme sleep deprivation have shown that even healthy subjects can begin to exhibit signs of temporary psychosis. That's right, delusions, paranoia, detachment from self. All because your brain, in its desperation, is trying to interpret a world it no longer fully understands. But don't worry, you're still you. Deep inside, that quiet observer remains, watching, waiting. Your immune system by now is waving a white flag. Cytokine levels are rising. Your body's inflammatory response is going haywire. If you got a cut right now, it would heal more slowly. If a virus wandered in, you might linger longer. Your natural defenses are drowsy, not gone, but slower to react, as if your body is sleepwalking through its own battlefield. Let's zoom in again, microscopically, softly, down into your hippocampus. This seahorse-shaped region in your brain is crucial for forming new memories. But right now, it's like trying to write in a notebook with a soggy pencil. You're not encoding new experiences properly. Tomorrow you may remember fragments of today, but it'll feel like a fuzzy dream, hazy and slippery. There's a famous case worth mentioning here: Randy Gardner, the high student who stayed awake for 64 hours in 1964, just over 11 days. Under observation, he experienced mood swings, concentration issues, memory lapses, and hallucinations. But remarkably, after a few solid nights of sleep, he recovered fully. Scientists still marvel at the resilience of the human mind, even when pushed so far past its limits. But that brings us to a beautiful open question. Why does the brain break reality before it breaks the body? Why hallucinations before organ failure? Why confusion before collapse? Some theories suggest it's evolutionary. If the brain can force you to rest by making consciousness unbearable, maybe it prevents you from doing long-term damage. Others believe it's simply a side effect of the way neural pathways require downtime to reset. Without that maintenance, mental static takes over. Meanwhile, your glymphatic system, yes, glymphatic with edge, is still on standby. It's the network in your brain that clears away waste products like a gentle internal janitor. But it only activates during deep sleep. So right now, your neurons are operating in a cluttered workspace, piled high with used-up neurotransmitters and metabolic leftovers. And speaking of cluttered, your default mode network, the part of your brain that lights up during daydreaming and self-reflection, is sputtering. That's why introspection feels odd. Your sense of time, warped, past, present, and future blur together. You might even lose your sense of where you end and the rest of the world begins. You're becoming porous. Light seeps in strangely. Sounds echo. The edges of reality grow soft, but not in a frightening way. Think of yourself now as drifting inside a warm sensory bath. The boundaries are blurred, but the water is gentle. Sleep hovers just outside reach, like a cat curled on the windowsill, watching you with slow blinking eyes. Even now, your lungs rise and fall, your heart ticks on, and your bloodstream still bubbles with oxygen. Mitochondria still hum with energy production. The biological orchestra continues, even if the conductor is dozing off backstage. You haven't slept in 72 hours, and yet you're still glowing faintly in the dark. You haven't slept in 4 days. By now, your body isn't asking for rest. It's begging. Not politely either. It's dragging metaphorical fingernails across the chalkboard of your mind, sending desperate signals through every system it still has control over. But those signals, you're barely catching them, like whispers in a windstorm. Your emotional regulation has also taken a nosedive. The amygdala, the part of your brain responsible for emotions, especially fear and anxiety, is now wildly overactive. Tiny inconveniences, spilled tea, a slow-loading app, a misplaced sock, could feel like existential threats. You might cry. You might laugh at things that aren't funny. You might swing between the two in a dizzy, disorienting dance. Congratulations, you've entered the emotional rollercoaster stage of sleep deprivation. There's a scientific explanation for this. Without adequate sleep, the prefrontal cortex, that responsible, rational adult in the brain, loses its grip on the amygdala. So your brain becomes more reactive, less restrained. Like giving your inner drama queen a megaphone and a spotlight. Your motor control is starting to fray too. Movements become clumsier, your coordination less reliable. It's like your body is being puppeteered by someone wearing oven mitts. Reaction time slow. Even basic tasks like brushing your teeth feel strangely complex. Too many steps, too many moving parts, and your pain threshold dropping. Studies have shown that sleep deprivation actually makes you more sensitive to pain. So that ache in your lower back, the stiffness in your neck, the mysterious cramp in your foot, they all feel just a bit more intense, like your body turned up the volume on discomfort. Here's a quirky fringe fact: in rats, prolonged sleep deprivation can literally be fatal. Scientists aren't entirely sure why. It's not organ failure. It's not starvation. It's something else. Maybe the immune system collapses. Maybe it's thermoregulation. Maybe it's just that the body eventually forgets how to live without pause. But one thing is clear. Sleep isn't optional. It's required maintenance, not a lifestyle choice. And yet, humans are strangely resistant to that truth. We treat sleep like an inconvenience. Something to delay, to override with caffeine, to brag about skipping. But the body disagrees. And when it disagrees for long enough, it begins to shut things down. That's where microsleeps come in. Your brain, in desperation, will begin taking tiny naps without asking permission. Just a few seconds at a time. Enough to sneak in a moment of rest. Your eyes may remain open. You may even still be standing or typing. But for a flicker of a moment, consciousness shuts off. Your brain collapses into itself like a sigh. Then reboots. Microsleeps are dangerous because you don't know they're happening. One moment you're driving, walking, talking. And the next, you've lost 5 seconds. Like a broken film reel spliced at random. At 96 hours, 4 full days, you are now functioning in a state comparable to being legally intoxicated. Reaction times, memory, speech all impaired. You may slur your words, forget basic facts, get lost in familiar places. This isn't exaggeration. It's measurable in lab studies. Your brainwaves resemble those of someone in a twilight stating, not awake, not dreaming, but something in between. And here's where it gets existential. People often report an eerie sense of disconnection at this stage. From their thoughts, from time, from themselves. It's as if you've become the dream of your own body. Even the circadian rhythm, your internal clock, begins to fall apart. Usually it's synchronized by light and melatonin, humming along in a neat 24-hour cycle. But now, it's wobbling, out of sync. You feel tired at strange hours, alert when you shouldn't be. Your body is trying to find some semblance of rhythm, but the orchestra has no conductor and half the instruments are asleep. Yet, even amidst all this disarray, your body still fights for balance. Your hormones are adapting. Cortisol, the stress hormone, rises. Ghrelin, which triggers hunger, spikes. Leptin, which signals fullness, plummets. That's why you feel hungrier when you're sleep deprived, and more likely to reach for sugar, fat, carbs. Anything fast and comforting. Your body is trying to bribe you with snacks in lieu of sleep. Let's return to your dream circuits for a moment, because here's a delightful paradox. You're not dreaming, but parts of your brain act as if you are. The visual cortex, the limbic system, the regions involved in imagery and emotion. They're lighting up randomly. That's why your hallucinations become more vivid, more story-like. You're dreaming on your feet. And some people, especially those with vivid imaginations or a history of lucid dreaming, may begin to blend waking life with dream logic. Doors appear where there were none. Sounds seem to echo from far-off places. The world becomes soft-edged, watercolor-tuned. Strange, but not always unpleasant. Scientists still don't know exactly why hallucinations become so common in prolonged wakefulness. Is it a coping mechanism, a warning sign, a last-ditch effort by the brain to simulate internal order when the external world stops making sense? One theory suggests that hallucinations are the brain's default mode, like a screensaver. When no input is coming in, or the input is too scrambled to make sense of, the brain simply creates. It fills in the gaps with whatever it has lying around. Memories, fears, half-formed thoughts, dreams. And so you find yourself wandering this strange borderland.
Not asleep, not awake.
Just drifting, a consciousness afloat on a vast dark sea. But the sea isn't stormy, it's calm, moonlit, and somewhere in the distance, there's the faint suggestion of sleep, waiting patiently for your return. By the time you reach the 5-day mark, that's 120 hours without sleep. Your body is running on fumes, but the hallucinations, they're running on full power. You may see things moving that aren't really there. Flickers of light, shadowy figures, swirling patterns on blank walls. Your brain has entered full dream mode while awake, and it's not asking for your permission. Trees seem to breathe. Furniture might sigh. Colors feel louder. Time, forget it. Hours melt into each other like warm wax. Minutes stretch like rubber bands. This isn't fiction. It's been observed in real, life sleep deprivation studies. The 1964 Randy Gardner experiment, often cited in this context, saw a high school student stay awake for 11 days. By day 5, he couldn't name simple objects, forgot why he was speaking mid-sentence, and claimed to see a black and white road sign person watching him. He wasn't alone, just in his head. Your brain's default mode network, the part that idles when you're not focused, starts to misfire. It begins making connections where none exist. Patterns become stories. Static becomes whispers. A breeze becomes someone calling your name. In other words, your reality filter is offline. You might find yourself talking to people who aren't there, having arguments with your own inner voice, or believing, quite sincerely, that time has stopped entirely and you're trapped in a repeating loop. It's not scary, not yet, just surreal. And here's the truly curious thing, despite all this chaos, you may have moments of absolute clarity, fleeting seconds where your thoughts align like a flock of birds, and you feel connected to something deeper. A memory, a feeling, a realization about life, the universe, and your place in it. Sleep deprivation has a weird way of lowering the noise floor. It silences the everyday chatter in your mind and allows deeper thoughts to bubble up, sometimes profound, sometimes strange, sometimes both. Now let's dip into a fringe fact. In certain spiritual practices, intentional sleep deprivation is used to induce visions or altered states. Some monks and shamans claim that beyond the wall of exhaustion lies a kind of clarity, a mystical insight only accessible to the sleepless. Whether that's biological or metaphysical is still very much up for debate. But for you, right now, there's no ritual or intention, you're just tired. Bone tired. Your cells are grumbling, your muscles twitch randomly. Even blinking feels like effort. You start to lose sense of self. Literally. The brain's parietal lobe, which helps you understand where your body ends and the world begins to shut down. You might feel like your arms are floating away, or that your body is expanding, merging with the room, melting into the bed. It's disorienting, yes, but it's also strangely peaceful, like becoming part of the air itself. Meanwhile, the immune system is waving a white flag. T cells, your immune army, aren't responding properly. Inflammatory markers rise. Your body's defense systems are saying, you go ahead and keep ignoring sleep, but we're sitting this one out. That's why people who don't sleep get sick more often. The body simply can't protect itself without rest. But despite all this inner chaos, something magical continues. Your heart still beats, your lungs still rise and fall, oxygen is still flowing, cells are still making energy. It's a testament to how stubbornly life clings to itself. Even in exhaustion, your body doesn't quit. It adapts, compensates, rewrotes, and even if your short-term memory is completely shot, you can't remember why you walked into a room, what you just said, or where you put your phone, you still carry an echo of your identity, your habits, your emotional truths. Those are deeper than the sleep-deprived fog. They live in the limbic core, the most ancient part of your brain, and they hold on tight. There's something poetic about this. Even when your rational brain falls apart, the emotional you remains, like a lighthouse on a dark coast, blinking steadily through the storm. But storms don't last forever, and even if you resist, your body is counting down. Sleep is not just a biological need, it's an inevitable force, like gravity. Sooner or later, your body will shut you down. You'll blink, and instead of opening your eyes, you'll drift. There won't be a moment of choice, no final conscious act, just the fade. And perhaps that's the strangest part. After all this effort to stay awake, after hallucinations and confusion and identity drift, sleep comes quietly like a cat curling into your lap. Uninvited, but undeniable. And it doesn't judge you for the delay, it just pulls you in, softly. Finally, you wake up, if you can call it that, in a body that doesn't quite feel like yours anymore. Muscles ache in weird places. Your eyelids feel like wet towels. Thought moves like molasses. Even after just a few hours of fragmented sleep, microsleeps snatched by a body on the brink, you're not rested, not really. At this stage, the brain is still reeling. You might find yourself stuck mid-sentence, forgetting what word you were about to say. You walk into a room and stop, staring at nothing, trying to remember why you came in. It's like your working memory, that mental whiteboard where you sketch your to-do list and reminders, has been wiped clean. Here's the science: prefrontal cortex impairment. This region is your command center, responsible for planning, decision-making, and focusing your attention. With prolonged sleep deprivation, the prefrontal cortex takes a backseat, and what takes the wheel? Raw emotion. Your amygdala, the brain's emotional alarm bell, starts overreacting to everything. A minor inconvenience feels catastrophic. A small criticism sounds like betrayal. It's like every radio in your emotional control room has been turned up too loud. Ever cried at a commercial after an all-nighter? Blame that. There's a reason sleep-deprived people are often irritable, impulsive, or overly sensitive. It's not a character flaw, it's just a wiring issue. Sleep keeps the prefrontal cortex and the amygdala on speaking terms. Without it, they're like co-workers ghosting each other mid-project. Meanwhile, your body's systems are now actively working against you. Insulin sensitivity drops, meaning your body struggles to regulate blood sugar. That's why you might crave sugary snacks, even if you're not technically hungry. It's not willpower, it's biochemistry shouting, "Give me fast fuel before I collapse." And guess what? Your body temperature may be slightly off. You might feel a chill when it's not cold, or overheat when everyone else is fine. This is your hypothalamus, the brain's internal thermostat, failing to maintain its usual precision. All the while, you're still trying to function. But here's a weird, fringe fact: some rare individuals carry a mutation in the DEC2 gene that allows them to function on far less sleep than the rest of us. We're talking 4 hours a night and no measurable cognitive decline. Scientists are still studying how this gene rewires their circadian rhythm and boosts cellular repair during waking hours. It's rare, less than 1% of the population, but they exist. Basically, real-life superhumans who won the biological lottery. Back to you. By this point, sleep isn't just something you crave, it's something your brain is simulating, whether you like it or not. Even when your eyes are open, microsleeps can strike, brief, involuntary lapses into sleep that last a few seconds. You're technically awake, but your brainwaves say otherwise. It's like someone flipping your switch on and off without asking. These moments can be dangerous, especially if you're, say, driving. But even lying in bed, they create confusion. You might start dreaming mid-sentence. You say something odd out loud and then forget you said it. The boundary between dream and reality frays like worn-out thread. And here's where things get truly surreal. Your visual cortex, deprived of rest, starts inventing data. You may see bugs crawling in the corner of your eye, or lights that aren't there. You might hear a voice calling your name from another room when you're completely alone. These aren't full hallucinations yet. They're called hypnagogic intrusions, fragments of dreams slipping into the waking world. Sleep, at this stage, becomes inevitable not because of fatigue, but because your neurotransmitters are crashing. Serotonin, dopamine, norepinephrine, they're all misfiring. Mood dips. Focus disintegrates. You might feel like you're floating above your own body, watching someone else pilot you through daily tasks. And yet, somewhere in the background, the circadian rhythm ticks on. Even with sleep deprivation, your internal clock still tries to keep time, body temperature, hormone release, digestion, all following the 24-hour rhythm set by light. But without sleep anchoring it, the rhythm starts to slip. Your melatonin release is confused. You feel tired at noon and wired at 3 a.m. You're a time traveler without a map. At this point, scientists still aren't sure exactly why extended wakefulness is so catastrophic. Some theorize it's due to glymphatic system failure. That's the brain's night, cleaning crew, flushing out metabolic waste while you sleep. Without it, toxic byproducts like beta-amyloid can build up, potentially contributing to neurodegeneration over time. Yes, staying up too long doesn't just make you grumpy, it may age your brain. But there's a flip side. Even in this tired, fogged-out state, your brain might still produce something beautiful. A creative idea, an unexpected insight. A strange little poem that pops into your head as you gaze at the ceiling. Some artists and inventors claim their most surreal ideas came after sleepless nights. Think Dalí's paranoid critical method. He used microsleeps to catch strange, dreamlike images. Or Thomas Edison, who believed naps should be interrupted right before true sleep to catch inspiration mid-fall. The tired brain dreams with its eyes open. But it's a double-edged sword. For every spark of brilliance, there's a canyon of confusion. For every flash of insight, a fog of forgetfulness. And eventually, even those moments fade, you lie back. The room shifts slightly. Maybe it's just your perception, your limbs feel distant. The air feels heavier, and somewhere behind your eyes, your brain whispers one final request: please, just let me sleep. You're now entering the blurry, dream-adjacent stage of wakefulness, where time folds in strange ways and your thoughts refuse to line up politely. Each moment begins to feel like déjà vu, like you've lived this part of the day before, or maybe dreamt it. It's hard to say. Your brain is now fully improvising its way through consciousness, like a tired actor with no script. At this point, your body's exhaustion has gone beyond tired muscles or heavy eyelids. The fatigue has gone cellular. Inside your body, your immune system is flagging. Normally, sleep helps regenerate white blood cells and release cytokines, chemical messengers that target inflammation and infection. But now, those reinforcements haven't shown up. You're more vulnerable to colds, flu, and anything else floating in the air around you. There's a real science fact for this. After just 24 hours without sleep, natural killer cells, which help destroy virus-infected cells, drop in number by up to 70%. That's not just tired, that's defenseless. Meanwhile, your brain has started showing a peculiar new pattern. Entire sections of your cortex begin to go offline briefly, even though you're still awake. Think of it like rolling blackouts in a city. A few streets lose power while others remain lit. This isn't full sleep, and it's not full wakefulness. It's something in between. Scientists call it local sleep, tiny neural pockets shutting down independently, like overworked clerks putting up back in 5 signs. It's here that strange things begin to happen. You might reach for your phone and accidentally grab your coffee mug. You might hear your name and realize it's just a chair creaking. Sensory processing starts breaking down, mixing signals in odd ways. Your thalamus, the brain's relay station, is now transmitting on the wrong frequencies. One fringe theory. These disturbances resemble the early stages of REM intrusion. That's when parts of REM sleep spill over into wakefulness. It's often associated with narcolepsy, but under extreme sleep deprivation, healthy people experience similar symptoms: vivid imagery, sudden muscle weakness, and even sleep paralysis while awake. Yes, your body can literally start dreaming before you even fall asleep. And let's not forget your sense of time, that fragile framework that holds reality together. By now, it's coming apart. Minutes stretch like taffy, hours compress into blinks. You feel like you've been awake for days, or maybe it's only been one long, continuous hour. Your internal clock or circadian pacemaker is now spinning without calibration. There's an open scientific debate here: does the brain have a backup clock when the main one fails? Some researchers suggest secondary timekeepers exist in the gut or even in the retina, providing primitive time cues. But without sleep, these systems can't coordinate. It's like a band playing without a conductor, everyone drifting into their own tempo. Meanwhile, in the bloodstream, cortisol, the stress hormone, has been elevated for hours. At normal levels, cortisol helps keep you alert. But prolonged high levels, not great. It messes with your metabolism, increases anxiety, and suppresses mood, regulating neurotransmitters like serotonin. That's why everything suddenly feels a little too much. Light feels too sharp, sounds are irritating. Your own thoughts start looping like a scratched record. You think about sleep more and more. You fantasize about it. You plan for it, even as you actively avoid it. It's no longer rest, it's a craving. This is when people often start to talk to themselves more, not out loud necessarily, but in their heads. The mind reaches for structure, so you narrate your actions. You repeat simple tasks to yourself: keys, wallet, phone, just to make sure you don't forget. But forget you will. Short-term memory is now critically impaired. Your hippocampus, the region that helps form new memories, isn't syncing properly with the rest of your brain. You read a paragraph and forget the beginning by the time you reach the end. You walk through a doorway and forget where you were going. And yet, the brain keeps trying. Even in this frayed, fogged-out state, your neurons fire on, your heart pumps, your breath comes and goes. Red blood cells continue their infinite commute, ferrying oxygen to every corner of your body. But now you're running on fumes. Not just physically, but neurologically. Which brings us to an eerie phenomenon known as microdreams. Fleeting bursts of imagery that flash behind your eyes for a second or two before vanishing. These are not full dreams, they're fragments. Half thoughts that arrive uninvited. A hallway, a waterfall, a childhood bedroom, and then gone. Scientists still don't fully understand why microdreams happen. Are they a form of emergency brain maintenance? Or are they simply evidence that your mind, left unguarded, slips into the dream realm whether you permit it or not? One thing is certain: if dreams are the language of your subconscious, then sleep deprivation turns up the volume. The longer you stay awake, the more your inner world starts leaking into the outer one. And still you remain awake. Even now, some small voice in the back of your mind insists you're okay. That you can push a little longer. Finish the task. Watch one more episode. Scroll a little more. But beneath that voice, your body whispers something different. Let go. You're still here. Still clinging to wakefulness. But now, you don't so much think as you float through thoughts, like a leaf caught in a slow-moving current. Your brain, running low on every resource it relies on, is quietly repurposing its systems. It's entering survival mode. Let's be clear, this isn't just tired. This is the beginning of cognitive collapse. Your prefrontal cortex, the command center responsible for logic, planning, decision-making, and impulse control, is now on a part-time schedule. It's no longer regulating your emotions properly. You become reactive, weepy, or weirdly giggly. You might start laughing at a light switch, or crying because you forgot where you parked, even if you never drove. Here's a real science fact: in sleep-deprived brains, the amygdala, your emotional danger detector, becomes hyperactive. Meanwhile, your prefrontal cortex becomes less connected to it. That's like having a smoke alarm that keeps going off while the fire department's radios are down. This is why, after enough time without sleep, People become more emotionally volatile. You overreact to tiny things. You might snap at a loved one, or stare at the wall, overwhelmed by the sheer idea of making toast. And then there's the fringe stuff. The weird territory where science meets the surreal. By now, your default mode network, the network responsible for daydreaming and self-reflection, begins to operate untethered. Some researchers believe that this is the moment when hypnagogic hallucinations begin. These are vivid sensory experiences that appear just before sleep. But now they arrive while you're fully awake. You might see a shadow move across the room, hear a door close that was never opened, smell cookies that don't exist. And here's the open debate. Are these hallucinations just the brain misfiring under stress? Or are they ancient circuits activating, remnants of a mind designed to blur reality as it enters deep rest? Some anthropologists suggest that hypnagogia was once a gateway to creative insight, vision quests, even spiritual experiences. But in your case, it mostly just feels weird. You rub your eyes, you blink, but the shimmer in the air doesn't leave. Time has collapsed now. Hours lose their grip. Your sense of self begins to fray at the edges, and yet, your body still fights to keep going. The suprachiasmatic nucleus, your internal clock, is still trying to tell you what time it is. It's failing, but it's trying. Your pupils remain slightly dilated. Your melatonin levels are scrambled. You're not getting the usual chemical lullaby that tucks you into sleep. Instead, your brain keeps releasing adenosine, a chemical that builds up the longer you're awake. It's like biological debt. Normally, when you sleep, adenosine is cleared out. But now, it just keeps piling up, dragging your brain into deeper and deeper exhaustion. You are becoming a ghost inside your own skull. Functional, yes, but barely. This is when microsleeps start to appear. A microsleep is when parts of your brain literally fall asleep for a few seconds while you remain awake. Your eyes might still be open. You might even continue typing or walking. But for 2 to 10 seconds your brain goes offline. It's terrifying and completely uncontrollable. Drivers have crashed cars. Surgeons have frozen mid-operation. Students have blinked and missed entire pages of lecture in animal studies. Rats deprived of sleep for extended periods develop severe physical and neurological damage. Some even die, not from exhaustion, but from immune system collapse. Their bodies simply can't repair, defend, or regulate anymore. And yet, your mind continues to reach for some meaning, some coherence in this haze. You might now start speaking to imaginary companions. You might mutter things to yourself that don't make sense. You might start to believe your thoughts are being narrated by someone else. Not because you're going crazy, but because your brain's sense of authorship, that built-in narrator, has lost track of the script. You begin to dissociate. Your hand doesn't feel like your hand. Your voice sounds like it's coming from another room. You wonder if you're dreaming, but you're not. And yet, the barrier between sleep and wakefulness, between dream and day, has grown so thin it's barely there. You lie down, or sit, or wander in circles. You crave unconsciousness, but it won't come. This is a kind of torture your body isn't designed for. Even the US military considers sleep deprivation one of the most effective forms of psychological manipulation. The body breaks. The mind follows. But here's a strange glimmer in the dark: your brain doesn't give up. Even now, it's trying to heal. Neurons are firing slower, yes, but still communicating. Your blood vessels are constricting, but still carrying nutrients. Your heart beats on, thudding like a distant drum. One breath, another. You're still here. Not fully awake, not quite dreaming, just drifting somewhere in between. You're still awake. But awake no longer means what it used to. The edges of your consciousness blur like watercolor left out in the rain. Thoughts melt before they're finished. You reach for memories and find only fragments. Time feels thick like honey. And you're swimming through it, slow and unsure if you're going forward at all. By this point, your sleep debt isn't just affecting your mood or memory. It's seeping into your biology, changing how your body functions at a molecular level. Let's start with your immune system. Here's a real science fact: even one night of missed sleep reduces the production of natural killer cells by up to 70%. These are the microscopic soldiers that attack viruses, rogue cells, and pre-cancerous mutations. Without sleep, your defenses are down. You're more vulnerable to infection, inflammation, and long-term disease. But now, you've gone far beyond one night. Your white blood cells are malfunctioning. Your cytokine levels, the chemical messengers that regulate immune responses, are all out of tune. Some are too high, sparking inflammation. Others are too low, leaving you defenseless. And it's not just your immune system unraveling. Your metabolism is in freefall. Your body, unsure when it will rest again, starts hoarding calories and releasing ghrelin, the hunger hormone. Meanwhile, leptin, which signals fullness, drops. The result: you crave sugar, salt, and fat. Midnight snacks become 3 a.m. feasts, and your body stores every bit of it, like a squirrel in winter. This is why chronic sleep deprivation is tied to obesity, type 2 diabetes, and even metabolic syndrome. And now comes a weird science. Tibbing research have observed that when fruit flies are sleep deprived long enough, they eventually drop into a kind of sleep paralysis while standing. Their wings still buzz faintly, their legs quiver, but their minds are unreachable. It's unclear if they're asleep or just disconnected. In humans, the boundaries are just as vague. Some researchers call this wake-sleep dissociation. You're awake in body, but dreaming in mind. You may begin to have false awakenings. Moments when you're sure you've finally fallen asleep, only to realize you're still staring at the ceiling. You feel your body sink into the mattress, but when you blink, the room is exactly the same. Time loops, the clock hasn't moved. Déjà vu plays tricks on your sense of continuity. And then comes the existential weirdness. You forget why you started staying awake in the first place. You forget if this is an experiment, a challenge, a punishment, or simply your life now. Here's the open scientific question. Why exactly do we need sleep in the first place? Yes, we know sleep restores energy, consolidates memory, and regulates mood. But the deeper why remains mysterious. Some scientists argue that sleep is a brain-cleansing system, like an overnight dishwasher. Others believe it's essential for pruning neural connections, keeping your thoughts from becoming an overgrown jungle. Still others suggest it's not a function at all, but a legacy, a holdover from evolution when nighttime meant danger and stillness meant survival. But even if we don't fully understand why we sleep, we know what happens when we don't. Your heart is now struggling. Sleep normally lowers blood pressure and slows your heart rate, giving your cardiovascular system time to rest. Without that, the wear and tear add up. Your risk of heart attack and stroke creeps higher with every hour you stay awake. Your gut suffers too. Your digestion slows, your gut flora, the helpful bacteria that support immunity and mood, get out of sync. Some studies suggest that long-term sleep deprivation may even alter the permeability of your gut lining. That's right, it might literally make your digestive system leakier, and perhaps strangest of all, your DNA begins to misbehave. Research has shown that after just 1 week of poor sleep, over 700 genes show altered expression. Some of these genes regulate immune function, stress responses, and metabolism. Others are linked to aging and cancer. In other words, staying awake too long rewrites your cellular script. You are no longer running your original programming. You've become a soft, flickering signal, fuzzy at the edges. Your body continues to go through the motions, but the harmony is gone. You're no longer an orchestra, just scattered instruments playing out of tune. And still you do not sleep. You lie back, eyes half-lidded, breath uneven. You hear the hum of electronics, the faint tick of the wall clock, the distant shuffle of a neighbor's footsteps. Every sound feels like a wave breaking over your thin, exposed mind. This isn't insomnia anymore. This is something else. Your brain is like a city where the power grid is failing. Streetlights blink at odd intervals. Trains stop in tunnels. Phones ring unanswered. But somewhere, deep in the center, a control room still flickers. A tired technician keeps flipping switches, hoping to restore order. You are that technician, exhausted, overloaded, still trying, still here. The line between reality and dream begins to shimmer. You're still awake, technically, but your perception now moves in waves. One moment, you're looking at the ceiling. The next, the ceiling seems to breathe. Shadows tilt in place. Your thoughts arrive unannounced, like strangers at a bus stop. You blink. An entire minute slip past like a skipped scene in a movie. This is microsleep. Brief, involuntary lapses into unconsciousness that last mere seconds. You don't even notice them, but your brain does. Little blinks of escape. Your neurons have decided, without your permission, that sleep is no longer optional. Here's a real science fact: during microsleep episodes, portions of the brain actually power down. Even if your eyes remain open. Functional MRI scans show that your attention circuits flicker off, even while you're mid-task. It's like being piloted by a ghost who sometimes vanishes to go grab coffee. Microsleep is why sleep-deprived drivers drift across lanes, why workers forget steps in routine tasks, why your hands may suddenly stop mid-motion unsure of what they were doing. Now let's dial inward. You're starting to lose proprioception, your sense of where your body is in space. Your limbs feel disconnected, as if they belong to someone else. You reach for a glass and miss it by inches. Your fingers seem to float just behind your intent. There's a certain elegance to it, oddly enough. Like you become a ghost inside your own skin. And now the hallucinations start. Not the dramatic Technicolor visions Hollywood loves, but soft flickering intrusions. A whisper of someone saying your name. A shape gliding just out of sight. The feeling that someone else is in the room, watching. Here's a fringe science tidbit. Some researchers believe that sleep deprivation activates the same brain circuits triggered by REM sleep dreams. But while you're still conscious, you're dreaming while awake in fragments. The walls between waking and dreaming are dissolving. And here's an even weirder idea. What if these hallucinations aren't just malfunctions but reboots? Some neuropsychologists suggest that your brain, when deprived of its nightly maintenance cycle, starts to run emergency cleaning scripts in real time. These scripts, fragments of dream logic, image, and voice, are jarring because they weren't meant to run while you're conscious. They're back-end processes slipping into the foreground. The open scientific debate here is this: are these hallucinations simply noise, or are they a form of emergency cognition? Some theories propose that your brain is trying to keep functioning by improvising reality, pasting together internal guesses when sensory input becomes too unreliable. Meanwhile, your emotional regulation is gone. Your amygdala, the brain's fear center, is hyperactive. Small worries feel enormous. Your patience wears then. You feel jittery, then hopeless, then inexplicably euphoric. It's a chemical rollercoaster without a seatbelt. This is why sleep deprivation is linked with mood disorders, especially depression and anxiety. Without REM sleep, your brain can't properly process emotional experiences. It's like trying to untangle headphone wires in the dark with numb fingers. And yet you're still trying. There's something poetic about that. Your brain, despite the chaos, continues to whisper one more moment. Even though it's malfunctioning, it's still reaching toward order. Still firing signals. Still attempting to maintain some kind of fragile continuity. You lie there, body buzzing with fatigue, and wonder what if you never sleep again. Not out of insomnia or choice, but as a new state of being. A forever awake version of yourself. Would your body adjust? Would your brain build workarounds? Some scientists hypothesize that certain sea creatures, like dolphins, sleep with only half their brain at a time. It's called unhemispheric slow-wave sleep. One hemisphere naps while the other stays alert, allowing them to surface for air and remain vigilant. Could humans evolve that way? No one knows. But what we do know is that every attempt to remain awake forever has ended the same way: collapse. Your body is not a machine, it's a garden. And gardens need cyclist sun and shade, action and rest. Without rest, the soil erodes, the roots dry out, the leaves wither. Even now, as you float in this strange, sleepless twilight, your body is begging for restoration. You begin to hear sounds that don't exist. A soft hum in the walls. A distant radio playing a melody you almost recognize. A knock that no one else hears. And the colors shift too. Blues deepen to inky purples. Light halos around objects. Your vision pulses in time with your heartbeat. Reality becomes a soft ocean. You are floating just beneath its surface, eyes open, but senses blunted. Time flows oddly. Fast, then slow. Past and present tangle like vines. And maybe somewhere in all this you feel a kind of awe. That your brain, pushed past the brink, doesn't give up. It adapts, improvises, and clings to meaning. Even as it forgets your name. It remembers you. You, who are still listening. You are still awake, though barely. The room is unchanged, yet everything feels altered. Like you've slipped behind reality's curtain. Now, something strange happens. Your immune system begins to falter. Not in a dramatic, cinematic way, but silently. Your white blood cells grow sluggish. Inflammation quietly builds. That small cut on your finger takes longer to heal. The ache in your joints lingers a little longer than usual. One real science fact: sleep is when your immune system resets and strengthens itself. Cytokines, proteins that target infection and inflammation, are released during deep sleep. Without rest, those reinforcements simply don't arrive. It's like going into battle with a half-empty army. And it's not just your immune system that's under siege. Your hormonal balance has taken a dive off a cliff. Cortisol, the stress hormone, is on an endless loop. Your insulin response becomes faulty, making it harder to regulate blood sugar. Leptin and ghrelin, which manage hunger and fullness, spiral out of sync. That's why sleep-deprived people often feel hungry but less satisfied, like trying to fill a leaking bucket with a teacup. Meanwhile, your muscles begin to weaken, not because they've been overused, but because they've been ignored. Growth hormone, which is crucial for tissue repair, is released during deep sleep. Without it, your muscles don't get patched up. Your body is like a mechanic's garage left empty all night. The tool's still there, but no one working. Now comes a fringe science tidbit. Some researchers believe sleep deprivation affects your gut microbiome. Yes, the bacteria inside you seem to follow a circadian rhythm of their own. When you disrupt yours, theirs gets thrown off too. And they're not happy about it. You might experience bloating, strange food cravings, or even changes in your mood. Because your gut, oddly enough, produces a large portion of your body's serotonin. That's righto. Your intestines are partly in charge of your happiness. So when sleep vanishes, everything downstream becomes tangled. And yet, the most haunting part isn't physical. It's identity. You're not just tired anymore. You feel unreal, detached. As though you're watching yourself from a slight distance, narrating your actions but no longer owning them. This is called derealization, a mental fog that often descends during extreme sleep loss. Your thoughts feel hollow. Your surroundings lose depth. The world seems like it's been painted onto a thin film hovering just out of reach. Scientists still debate why this happens. Some think it's a defense mechanism, a way to conserve mental energy by dimming perception. Others believe it's a form of neurological emergency shutdown, a blurry reboot until resources are restored. Either way, it's deeply disorienting. You look in the mirror and blink twice, surprised that it's your own face staring back. Except it doesn't quite feel like you anymore. You try to recall something simple, your childhood bedroom, your favorite food, the plot of a movie you just watched. But the memory won't solidify. It dances on the edge, just out of reach. You are forgetting things. Short-term memory is one of the first cognitive casualties of sleep deprivation. Your hippocampus, the brain's memory librarian, is drowsy and disorganized. It keeps misfiling new memories, tossing them into strange drawers, or losing them altogether. It's not that you're incapable of remembering. It's that your brain has stopped prioritizing what to remember, and now even time itself feels untrustworthy. Seconds drag. Hours skip. You look at the clock and feel like you're in a time loop. Everything repeats in echoes. Sounds seem delayed, light seems flickery, motion feels stuttered. One moment you think it's morning. The next, you wonder if you ever fell asleep at all. This is called circadian disintegration, when your internal body clock has lost its anchors. Without proper sleep-wake cycles, your circadian rhythm starts to float away like a balloon without a string. And here's an open question in science: can a human completely lose their circadian rhythm? In deep isolation studies, where volunteers spend weeks without sunlight or clocks, some people's rhythms completely unravel. They sleep randomly, eat at odd intervals, and experience free running time. It's unclear whether this is reversible, or if a new rhythm replaces the old one. So here you are, awake in the dark, a body buzzing with chaos, a mind trying to make meaning, and somewhere buried beneath all of it a quiet voice, the part of you that's still aware, still reaching for peace, still whispering, "I need rest." You curl into yourself, breathing shallow but steady. Your muscles twitch without warning. Your eyes glaze over. Your jaw aches from silent clenching. But beneath it all, your body is still holding on. You are exhausted, but not defeated. And though you can't yet sleep, you are so close. You float. No more urgency. No more wearing circuits or flashing internal warnings. Just this strange, suspended sense of almost sleep. Like you're curled inside a thought, softly spinning. Your eyes may still be open, but your brain is exhaling deeply. This is what scientists call sleep pressure reaching its peak. After hours, or even days, without rest, your brain stops negotiating. It's done playing polite. It's now insisting. Sleep is no longer a suggestion. It's a biological coup. One real science fact: researchers have found that certain parts of the brain can fall asleep independently, even while the rest of you stays awake. It's called local sleep. Neuron clusters in your motor cortex or sensory pathways begin to nap, leading to slower reaction times and mental fog. Even if your eyes are open and you feel awake, it's like a city grid where some neighborhoods flicker off before the rest, your body conserving energy, dimming what it can. Now for a fringe tidbit. There's a rare genetic mutation, found in only a handful of families worldwide, that allows people to function with just 4 hours of sleep per night without adverse effects. Scientists call them short sleepers. Their brains cycle through restorative sleep stages more efficiently. But don't get jealous just yet. Those people are biological anomalies. For the rest of us, cutting sleep leads not to superpowers, but slow unraveling. And the question that still fascinates researchers: why do we sleep at all? We know what happens when we don't. Cognitive decline, immune dysfunction, even shortened lifespan. But why we need to spend nearly a third of our lives unconscious is still open-ended. Is it for memory consolidation, emotional reset, toxin clearance in the brain? The truth may be all of the above, or none. Evolution doesn't always offer clear explanations. Sometimes sleep is just the cost of being conscious. Now, here you are, your breath is steady, your limbs are warm, your mind is like a slow-turning galaxy, vast and drowsy. You remember that little clump of neurons in your brainstem, the medulla oblongata, quietly orchestrating your every breath. Even now, it's monitoring CO levels, guiding the rhythm. And deeper still, below words and thoughts, your glymphatic system has begun to stir. That's the brain's nighttime cleaning crew. It flushes out waste, like beta-amyloid proteins, which are linked to Alzheimer's. While you rest, think of it as a gentle rinse for your most precious organ. Sleep isn't just passive, it's active repair. You don't just shut down, you restore. Inside your muscles, growth hormone pulses, helping with tissue regeneration. Your immune system reorganizes its cells. Your gut bacteria shift in composition. Everything you are, biologically, neurologically, chemically, leans into this moment of stillness. And slowly you begin to drift for real. The ceiling fades. The walls stretch wider. The room becomes a cocoon of stars. You're not just a person lying in bed anymore. You are a constellation of cells humming in harmony, orbiting rest. You are breath. You are heartbeat. You are quiet. One last thought floats through you. Soft, silly, barely tethered to logic. What if sleep is a love letter your body writes to itself? A nightly poem of care, of survival, of hope. You smile, or maybe you just feel like you did. And then, asleep. You are weightless now. The story, the science, the questions, they all fade like footprints in sand, gently swept by the tide. You're floating between thought and stillness, surrounded by quiet. There is no rush, no urgency to understand, no pressure to remember, just soft awareness, like the warmth left behind by sunlight after it's gone. Your body hums in low tones of calm, muscles softened, breath steady, each inhale cool as moonlight, each exhale a release. There is a comfort in knowing that rest isn't something you have to chase. It's something your body remembers, coded deep in your cells, practiced every night across a lifetime. Even when it feels out of reach, sleep is always circling back to you. You've done enough. You've made it here. You've let your thoughts wander, allowed your mind to question, and your body to listen. Now, it's okay to let go. The world will wait. The science will still be here in the morning. For now, imagine the quiet whir of your neurons dialing down. A soft wind through inner canyons, tiny stars blinking behind your eyes. Nothing needs solving, nothing needs finishing. This moment belongs to stillness. So rest easy, curious one. The rest is silence.